Hey guys, welcome to video 3 titled Double Angle Formulas. I hope you all are doing well. I'm doing pretty well myself, hanging in there. I've been just wanted to shout all of you out who've been reaching out, letting me know where you're at, coming in and dropping by at office hours, or just like keeping up with the Instagram. I know it's hard. There's a lot of different things kind of pulling at your attention right now. So at the end of every week, I encourage you to really think about, okay, what helped me, what didn't help me, and how can I make those changes? Being reflective is going to help you a lot. At least I can tell you it's helped me a lot in making my quarantine life and lifestyle the best possible. Anyway, without further ado, let's jump into exactly what topics this Delta Math will cover. So this Delta Math will cover really basic fractions. So adding and subtracting fractions, finding common denominators, really as simple as it sounds. So my video will not cover fractions. My video will briefly cover relationships of trig functions and more extensively cover double angle formulas. Let's go ahead and talk about, we already talked about fractions, so relationships of trig functions. So this question set, they're multiple choice, and on Delta Math, the default is that if they're multiple choice questions, you actually only get one attempt. The basic trig concept it's covering here, just how sine is opposite over hypotenuse, how cosecant is hypotenuse over opposite, all of those things, which is pretty straightforward. Then it's also covering reciprocal identities. So not only sine, cosine, and tangent, but also cosecant, secant, and cotangent. And then the third thing it's covering is something called cofunctions. So cofunctions we spent probably the least amount of time on. But if you've ever thought about, wait a minute, there is a relationship between cosine and sine, right? Sine and cosine are cofunctions. They're not reciprocal, but they're cofunctions. Same with cotangent and tangent, same with secant and cosecant. You look at angles that are complementary, meaning angles that add up to 90 degrees, those cofunctions will give you the same value. So an example will help you more than the way I just explained it. So think about it this way. Cosine of 40 degrees will be equal to sine of 50 degrees. Or tangent of 15 degrees be equal to the complementary of its cofunction. So the cofunction is cotangent, and the complementary value is 75 degrees. That's all you're doing. So on all of these problems, you're actually not using any particular numbers. So it's all conceptual multiple choice questions. So that is all we're doing with relationships of trig functions. Last but not least, we are talking about double angle formulas. So we are back on our identities. So for this lesson, we're focusing on double angle. And this is something we've already done. You should already know exactly what these double angle formulas are. We are only focusing on sine and cosine. And we're only looking at triangles that are positive or in the first quadrant. So quadrant number 1. There's only one double angle formula for sine right here, but there's 3 different cosine formulas, and you can use any 3 of them. This is a calculator active portion, so quick calculator spotlight. I asked you guys to download some kind of usable calculator, so you may use TAculator on your phone, Taculator, I don't know how you say it. Or I also gave you the link to download this TI SmartView. This calculator is really amazing. It looks just like this. It has all the same capabilities. So if you have access to a computer, definitely download this because it's really nice and straightforward. So I'm going to go ahead and do some practice problems. We are doing this practice problem right here. Always consider that your triangle in these problems is in the first quadrant. It's going to give you one trig ratio. So one whole problem will either ask you for sine or for cosine, never tangent. That's about it. So let's jump into the actual practice problem. All right, so using the same problem that we had on that PowerPoint slide, we are given that cosine theta is 4/5, and we're told that it's a positive acute angle, and these are the formulas that we are given. So let's go ahead and start with sine 2 theta. So we know that in order to find sine 2 theta, we only have one formula to plug into. So we know that to find sine 2 theta, we have to use 2 sine theta cosine theta. So let's go ahead and plug in what we have. We already have cosine theta, right? That's our given, that it's 4/5. So we know that it's 2 sine theta times 4/5. Now, how do we find sine theta? We have 4/5, right? If we have cosine is 4/5, we know that cosine theta is adjacent over hypotenuse, right? We know that it's adjacent over hypotenuse. So we can draw a triangle in order to figure out what sine theta would be, right? So we're in a positive, this is a positive triangle in quadrant 1, and this is the theta that we are referring to. We have that cosine, meaning adjacent over hypotenuse, is 4/5. So we want to find the side adjacent to theta and the hypotenuse, right? So that is adjacent 4 over hypotenuse 5. You can use the Pythagorean theorem, or just remember that your special right triangles will tell you that this side is 3. But you can always use Pythagorean theorem as well to find the other side of the triangle. We know cosine theta is 4/5, that's given, but now we know what sine theta is as well, which is opposite over hypotenuse, which is 3/5. So instead of sine theta here, I can plug in what sine theta is, which is 3/5 times 4/5. And then you can go ahead and plug that into your calculator. You've got 2 times 3/5 times 4/5. So the only thing you really need to remember here are your parentheses, or else you might get a little messed up. So your answer is 0.96. You can leave it as a decimal or as a fraction. So if you convert it to a fraction, you will get 24/25. So your answer can literally be 0.96 or 24/25, either one. This is your final answer for sine 2 theta. Now let's do cosine 2 theta. So cosine 2 theta, there's multiple ways to solve this problem. So let's start first with plugging it into this first equation. So we have, right, our given is cosine is 4/5, and we know that sine is 3/5. So we can literally plug in, so we are using that first cosine equation, so cosine squared theta minus sine squared theta. So we know that it's 4/5 squared minus sine theta, which is 3/5 squared. Same deal, you're gonna go to your calculator and you're gonna plug in those values. So once again, parentheses are really important. Make sure that you're squaring outside of the parentheses. That'll keep everything fully accurate. And you should get a value like that. So either 0.28 or if you converted it to a fraction, 7/25. Now let's try another one of the equations. So this is one version. Now you can be a little strategic, right? You don't want to use both functions. You just want to use the given one because you know that one's right for sure. So let's look for an equation that only uses cosine theta in order to find cosine 2 theta. If you take a second to look, then you see that it's this one right here. So now let's try to find cosine 2 theta using that last equation, 2 cosine squared theta minus 1. So this is a constant 2, right? Cosine squared theta, we know that cosine theta is 4/5, so all we need to do is square it minus 1. Okay, then we plug this in to our handy dandy calculators and you'll get the same answer, 0.28. So reminder, you can find the same value using all 3 of those cosine equations. That's it. This is how you show your work.